Let's do a question on inequality. This is a pretty short question, but personally, I feel that the second part of this question is extremely well set. It really requires you to have a deep knowledge and understanding on inequality in order to solve that part of this question. Anyhow, let's take a look at this first part of this question first. Without the use of calculator, you're supposed to solve this inequality algebraically. We have 2w minus 5 over w squared minus 3 greater than 0. We have a standard procedure of solving an inequality algebraically. First, we will be shifting everything to the left-hand side of this equation and to express the right-hand side to be 0, which we have already in this form already. And the next step, we have to express the left-hand side into all linear factors. We will have 2w minus 5 over, and here we can factorize to be w minus square root 3, w plus square root 3. Here we can see that we will be having 3 roots, 1, 2, 3. We can express these 3 roots on the number line. First root we have is minus square root 3. Second one, square root 3. Third one, 5 over 2. My suggestion is to probably put an open circle at the top of each root to specially indicate that we are not going to include that particular root because of this. It's not inclusive of the root itself. Alright, and we can actually just put some random values for each of this region to identify the sign of it. For this part here, maybe we can just put a value of w equal to 4, which will give me a positive value. Likewise, we will be doing for each of this region, we will be able to plus, minus, plus, minus. And we want it to inequality to be greater than 0. Greater than 0 will be positive. It will be this region here and here. Now we can write down our solution. We will have w between minus root 3 and root 3, or w will be greater than 5 over 2. Alright, that will be the first part of the question. And now the interesting part is the hence part. Solve this particular expression given x between pi and 3 pi over 2. Let me just write down the expression on the board first. We have 2 modulus of y minus 5 sine x over the y squared minus 3, and it is lesser or 0. And x will be between pi and inclusive of 3 pi over 2. For this type of inequality questions, actually we have quite a familiar process. Usually for inequality, the first part is the standard way of solving the inequality. After that, they will give you another expression whereby you need to make use of your previous solution in order to get the answer. Like for example, like this case, we might be thinking of replacing our variable w with something else in order to fit into the next equation. Then we can make use of the solution for the first part. And for this case, right, it seems like, right, I think it seems like we will be replacing our w with modulus of y. But there's a problem with this expression here. There's a sine x, right? There's a sine x. How come we have a third variable coming out into this picture here? One variable here, one variable, and there's a sine x. All right, but if you pause for a moment and think a bit more, right, actually this sine x is not really a big issue because they have provided us with a range here. And there's a reason why they provide us with this range. Perhaps let's draw a quick sketch of the function of sine x to have a clearer visualization here. This is a sine x graph, y equal to sine x. Alright, and if our values of x is being restricted to be between pi and 3 pi over 2, this is pi, this is 3 pi over 2. The region I'm interested in looking at is actually this particular region here, from here all the way to here. Okay, and I'll just put an open circle here because it doesn't include pi. You put a bold circle here to include this particular point, but it's not a big issue anyway for this part. Anyway, what we are going to look at is, right, between this and this, right, the value of sine x can only take on all negative values. Are you able to see that? It can only take on all negative values. That means this sine x is always negative. And if it's always negative, we can just simply cross this function over to the right hand side of this expression and it will just disappear. Like so let's say we cross this over to the other side, we will end up with a 2 mod y minus 5 over y squared minus 3. But we have to be careful because if it's always negative, we need to flip this sign. I will be able to get greater or equal to 0. At least when we do that, right, it gets closer. This is greater or equal, right? Better than this, lesser or equal to 0. All right, we almost got this, but there's still a last part. When we are replacing y with modulus of y, we are supposed to have modulus of y squared, but this is not. But we know that it's not a big issue because modulus of y squared is the same as y squared. We can just rewrite this with modulus of y squared. Let me just erase this. I'll just replace this with modulus of y squared. All right, now we have almost the exact same form except for this particular inequality sign, right? But nevertheless, we can actually just make use of the previous part solution now. From here, if the solution of this is this, the solution of this is just replace our w with modulus of y. I will be able to get minus square root 3 mod y lesser than square root 3 or modulus of y, replace this with mod y, I'll get greater than 5 over 2. Alright, but this is the part where a lot of students will make the mistake. Alright, because they just simply replace this without looking at this new expression. This is inclusive of 0. If it's inclusive of 0, it just simply means that we can actually include the root at the numerator. When we include the root at the numerator, we have to put a greater or equal sign for this particular root here. Right, now once we have this, we can solve this by using a simple sketch, or we can just make use of our algebraic method of splitting up the modulus sign. Like for this case, when we split up the modulus of y greater than minus square root 3 will give me y is element of everything. For this one, when we split this up, we will be able to get y between minus square root 3 and square root 3. And this is a end case, this end case. When we are doing an overlap between this and this, in fact, the solution for this particular expression here is just this, just y between minus square root 3 and square root 3. For this case, when we break it up, we will be able to get y greater or equal to 5 over 2, or y will be lesser or equal to minus 5 over 2. Alright, so let me just rewrite the final solution here. I will be able to get is y will be between minus root 3 and root 3, between minus root 3 and root 3, or y will be greater or equal to 5 over 2, or y will be lesser or equal to minus 5 over 2.